Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. So most of what we've been discussing is all about controllers. However, we're not quite done. There's still a lot left in controllers to go over. So within our controllers, the big one is going to be our SDN controllers, and we have to talk about their operations. So the SDN controller will define the data flow between the centralized control plane as well as all of the paired or matching data planes. So we can have multiple end devices, multiple switches, that all are sharing one controller plane. Each flow will travel through the network and must first get permission from the controller, which will verify the communication. The complexity as well as the more complex functions are going to be performed by the controller. Again, here the data plane is handling the bulk of the basic traffic. Anything complex has to come to the controller. And again, the controller has to give permission. So there are three main tables that we need to be aware of: the flow table, the group table, and the meter table. The flow table will match incoming packets to a particular flow and will specify the functions that are to be performed on those packets. A group table, again, this is going to be a flow table, may direct a flow to a group table, and this will trigger a variety of actions affecting one or more data flows. A meter table is basically a table that will trigger a variety of performance-related actions based on a flow, and that will include the ability to rate limit the traffic. So the QoS functionality is going to be part of the meter table, if you didn't know by the name meter. If we're talking specialized video, so some of the SDN tools will provide the features for automation of the network. This helps to accelerate application development and align infrastructure to requirements. So Cisco has developed the ACI to meet these objectives. So within the ACI, it's a hardware solution for integrating cloud-based computing and data center management at a higher level. So the policy elements of the network which should be removed from the data plane, this will simplify the way the data center networks are being designed and functioning. So the core components of our ACI are things like the Application Network Profile, ANP. This is a collection of endpoint groups. We have our Application Policy Infrastructure Controllers, APICs. We also have a Cisco Nexus 9000 series switch, and these are switches that will provide application-aware switching fabrics that will work with the appropriate APICs. So the APICs will position between the APNs and the ACI-enabled network infrastructure to allow for the translation. This is going to be more application-aware switching. Not quite switch labeling, but the switches are going to understand applications. So how do these function? They function by having essentially a piece of software that will interconnect the network profile. So we can have things like the VLANs or VMware or other web services separate from the actual underlying hardware. So the Cisco will have an ACI fabric, and this will be composed of the APICs, and you can normally find these like in the Cisco Nexus 9000 series switch. And they will use what's called the two-tier spine leaf topology, as we see in this diagram. So you're going to have these different leaves that connect to the actual core spine. And the leaves will actually connect to the APICs. When compared to an SDN, the APIC controller does not manipulate the data path directly. Instead, the APIs will centralize the policies, the definitions, and the programs. The leaf switches to forward the traffic based off of these defined policies. So here they're using policies to shape the flow of traffic. With SDNs, we have like a device-based SDN, and we're going to have some type of centralized application where the data plane will still be on each device. So the devices are programmed by applications running on the device itself or on a server. With a controller-based SDN, we have the controller being the actual hardware function, and we have an application sitting on top of it. It will still use a centralized controller that has knowledge of all of the devices in the network as shown below. The application can interface with the controller, and it can be responsible for managing the device as well as manipulating traffic. For example, here we can be using the OpenSDN controller as a commercial distribution of the Open Daylight controller. We also have a policy-based SDN, and this is very similar to controller-based SDNs, where we have a centralized controller that has views of all the devices. But here we have the policy-based SDN will include the policy layer that will orchestrate or operate at higher levels of the abstraction layer. It will use built-in applications that will automate the advanced configuration that will guide the individual through the workflow of the GUI. Here we're looking at the Cisco API CEM as an example of this type of SDN controller. If we're looking at the API CEN features, this is going to be the topology flow of the software so that you can understand how to manage those devices and how this will actually allow for the workflow to be created. This tool will allow us to discover and access devices, inventory of hosts and other assets. We can view the topology, and we can look at the policies and paths to our endpoints. We can also look at how administration can be done through visualization-based tools. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.